Anyone can safely tell us what is going to be a ratio? Yes. Is what?
Is what? Division.
So it has to do with comparison. So if we're speaking about a ratio, we're speaking about a ratio shows a relationship between different amounts. So if you're going to compare different amounts, we're speaking about the ratio. And then I think it's very important that we understand here. The job of a ratio is to compare. Yeah, it's to compare two amounts, two numbers. Yeah, but we usually use numbers. Ratio has to do with comparing of two numbers. And then, by the way, guys, like I'm not teaching physics here, whereby they will ask you in an examination and they ask you, what is the ratio? You never get a question like that one. What is the ratio? Because I can see people are taking notes. Like you just have to know what is this ratio thing that we are talking about, because it's very important in what we are doing in grade 12. At the same time, it's worth noting that the only way you're going to have a ratio is that if you compare two things. You can't have a ratio in isolation. One thing cannot have a ratio. So I have to compare two things for me to have a ratio. If I'm going to be comparing different amounts, then I can have a ratio. If there's no comparison, you're talking about one item. If I only have oranges, for example, like if I only have oranges, I can't speak of a ratio. A ratio has to do with a comparison of two things. You need to compare two things. You need to compare two numbers. You need to compare different amounts. So if you're just talking about one thing here, we can't have a ratio. Is that clear? Okay. Let's look at the following here. If we take the following example, what is going to be the ratio of strawberries? If we look at strawberries is to oranges, what would you say? Strawberries into, it's going to be 6 is to 3. Because how did you do that? You said, okay, how many strawberries do we have? We have 1, 2, 3, 4, 5, 6. Now, the other thing that I'm interested in is this. How do you write a ratio? There are different ways in which we can write a ratio. One way in which you can write a ratio, we can write it this way. We can say it's 6 to, you said it's 6 to 3. This is one way in which I can write a ratio. I'm saying there are 6 strawberries to 3 oranges. You see, it's a comparison. I'm comparing strawberries and what and oranges. At the same time, another way to write this thing, I could have written it this way. It's allowed to do it this way. And then you say 6 dot columns, and then you say 3. And then it's 6 is to 3. But now, this is not the only way in which you can write your ratios. Another way to write a ratio, we can write it in a fraction form, which is the useful one that we need today. So I can write this thing here. I start with the first one in the numerator. It's going to be 6 all over 3. Yes. You can't see this curve. You can't see me writing. Okay, let's do this. So you're saying I have 6 is to 3. Can you see this one now? Okay. And then we have 6. My aim is not to write here. I'm just summarizing which what is it that we are going to have here. And then, so here we can also have 6 to 3. This is the one that we're using in primary. Now, the ones that we're going to concentrate on here in high school are going to be mainly this one. Now, ratio can be simplified. We can simplify a ratio. Now, if we're going to simplify a ratio, we'll ask for which is there any value? Is there any common value that can go into 6 and 3? What is that value? It's 3. And then we'll ask which 3 goes into 3 how many times? So a simplified version of this is going to be 1 is to 2. I get 3 into 3 goes 1 time. And then 3 into 6 goes 2 times. So we need to understand that a ratio is not the actual amount. Doesn't necessarily have to be the actual amount. The ratio is the comparison of what of our amounts. Because what they are saying here, they're trying to say here is that we have 2. For every 2 strawberries, we need to have 1 orange. For every 2 strawberries, we're going to have 1 orange. Every 2, we are going to have 1 orange. So if we can simplify it a little bit further, we are going to do that. But what's very important to understand is a ratio is not the actual amount. A ratio is the comparison of these two things. It's not that thing per se. So if I say it's 2 to 1, it doesn't mean what I'm saying, which there are 2 strawberries and then there's 1 orange. I'm just saying the ratio is such that you have 2 to 1. So if I have 12, let's play around with this. Let's say I have 12 strawberries. Yeah, like you see, like such fruits, like they bring the English in you. These are the rare fruits. Like anyway, okay. If we have 12, how many oranges do we expect? We're going to expect how many oranges? Yes. We expect 6. Yeah, because we are saying the ratio is 2 is to what? Is 2 is to 1. Let's look at the following then. If we take soccer balls and basketball balls, if we're to compare these two, compare, what is going to be the ratio of these ones here? We start with the basketballs. Yeah, it's 5. It's 5 is to 8. Né? Now the question that we then follow is that can I simplify this any further? Again? No. So I can simply say, okay, this cannot be simplified any further. So I stop here. Okay, we're comparing 2 things. That's what we're busy with. Okay? We're comparing 2 things. And then after comparing 2 things now, what we're going to be using is this guy. So if I can give you the ratio and give you one of the items, can you get the other one? That's what we've been doing, man. I said to you, the ratio of strawberries to oranges is 2 is to 1. Okay? And then I said you have 12. If you have 12 strawberries, how many oranges are you going to have? You said to me you're going to have what? 6. How did you get that? You did it in what way? It just happened in the mind. All right, so matter of the mind. We'll leave it like that. Now, Tina, this is what we need, guys. Let's consider the following. Suppose we have a line segment AB. So we have a line segment AB. It's one thing. So if it's one thing, like I can't speak of a ratio. If I just have a line AB, it has 1 unit. So let's look at the following. We have line segment AB. And then AB is 21 centimeters. So if it's just one thing, I can't speak of a ratio. But here's what I'm going to introduce now. I introduce C. C divides AB in a ratio. It's dividing it in a ratio form, such that the ratio of AC to CB is going to be 3 is to 4. So we've seen this. We said this is in a ratio form. Okay? So this is not the actual length of AC. This is not the actual length of BC. But what is this thing here? This thing here is the comparison of AC to what? To CB. Are we together? Now, this is your AP. So you have the line. You can't speak of a ratio if it's just AB. This is just the line. So if you just have only this thing here, you can't speak of a ratio. So we have A here, and then we have B. When can I speak of a ratio? When I have something like this. So now I put C, and then I want to compare AC is to CB. You see now I'm comparing 2 things. Okay? I'm comparing AC is to what? Is to CB. AC is to what? Is to CB. Now, what is this ratio thing? What is this ratio? We spoke about this. You said you just did it now. You were able to tell me, okay, if I have this, then how many of this I'm going to have? Okay. So if this thing here is 21 centimeters, this whole thing here is 21 centimeters. And then now I want to know if this is 21 centimeters, what is going to be this thing here? And then what is going to be this thing here? That's what I'm interested in. Because you just told me, and I said we can get this thing. From what we just learned now, our mind, it has the computer to do it. It's simply all right. So we have the following. Now we want to get what is going to be AC is to CB. That's what we want to get. Now, what is this 3? Let's talk about it. What is this 3 is to 4? We're saying it's the ratio. So to think of ratio, it's like it's small pieces of the line. It's not the actual line. but are just pieces of the line. So what they're trying to say here is that here you need to have 4 pieces. They're going to have 4 pieces. So this is AC. As you can see, it's 1, 2, 3, 4 pieces. And then here you're going to have 3 of the pieces. So one thing that we know which from here to here, it's not 4. We know that. Obviously, if you have 21, and then we can't say from A to C, it's 4. It can't be 4. This is just the ratio. It's saying this AC to BC is going to be 4:3. So what I'm saying then is that this is 4P is to 3P. So when I'm going to be dealing with ratios, unlike when I'm dealing with the length, if I'm dealing with the length, I will write it as 21 centimeters. But if I'm writing a ratio, I'm going to write it as a piece. I can write it as 4P, I can write it as 4K. So here I decided to write this one as 4P is to 3P. Does that make sense? Yes, now, clearly, guys, like people are asking, Marcel, if you add 3 plus 4, what is going to be 3 plus 4? It's 7. Is this line 7? Line is not 7. The line is 21 centimeters. We spoke about that. But in comparison, if we compare it with AC, it's going to be 7 of the pieces into 3 of the pieces. It's going to be 4 of the pieces into 7 of the pieces. So, how then do we get what is going to be AC? We can get it AC by doing the following. I will tell them that starting from here up until today, I have 7 pieces. And then the 7 pieces that are going to be given as 21. Does that make sense? The whole 7 pieces is going to be given by what? By 21. And then 21 centimeters. If I divide by 7 and then divide by 7, it says P is actually going to be 3 centimeters. What does this mean? What does this mean? It means what this piece here is 3 centimeters. This here it's 3 centimeters. This is 3 centimeters. This is 3 centimeters. And then this is also going to be 3 centimeters, 3 centimeters, 3 centimeters. Now, what is going to be AC then? That's what they're asking me. They don't want to know what is P again. P I came up with it is my own variable. They want to know what is going to be AC. What is going to be AC? Let's look at this. I'm going to say AC is going to be given as 4 multiplied by P. What is P? I'll put 3 here. Then it means AC is going to be given as 12 centimeters. Guys, this is important. You should be able to calculate the length of something if you're given the ratio. If you're given the ratio, you should be able to move from the ratio to a length of something. Now, how would we get this one of BC? How would we get BC or CB? We can say BC is going to be equal to 3P. What is P3? And then it's going to give us what? 9 centimeters. Let's check the following. Is 9 plus 12 going to give us 21? 9 plus 9, 12 plus 9 is going to give us what? 21. So in other words, it means what after getting this one, after getting with this one here is 12 centimeters. I could have said 21 centimeters minus by 12 was going to give me whatever is missing here, which is going to be equal to what? 9 centimeters. Are we good then? Yes. Okay. Let's move from here then. Let's jump to these then. All right.
In triangle ABC, AB equals to 24 centimeters and AC equals to 26 centimeters. D divides AB in the ratio 5:3 and E divides AC in the ratio 8:5. So line AB is 24 centimeters and the ratio of line A, the ratio is 5:3. So D divides AB, this is yes, so A because of 5:3, it means AD, line AD it's 3p, then line DB is 5p. So to get P, we have to 24 equals to the sum of the two ratios. So it's 3 plus 5 equals to 8p, which means 24 equals to 8p. So we make Renyaga P. Renyaga P. So we divide by 8, then P equals to 3. So 8D equals to 3p. No, yeah, DB equals to 5p. So more wanang P, we substitute that 3. So 5 multiplied by 3, then line DB it's 15 centimeters. So to get AD, substitute P more 3, right? P more P. So it's AD equals to 3p, then 3 multiplied by 3 equals to 9 centimeters. So more. So then our and line DB equals to 15 centimeters and B80 equals to 9 centimeters.
Yes.
So line AC equals to 26 centimeters. So and the ratio of AC it's 8:5. So AE equals to 8K. Line AE equals to 8K and line EC equals to 5K. So the sum of the two ratios is 18K. So we equate the sum of the ratios and lay 26. So we want K, so we divide by 13, then regular K equals to 2. So AE equals to 8K. So more than K we substitute by 2, then 8 multiplied by 2 is 16 centimeters. So line AE equals to 16 centimeters, then EC equals to 5K. More than K we substitute by 2, 5 multiplied by 2 is 10 centimeters, so AC equals to 10 centimeters.
If I wanted to calculate the length of DP here, I could have said, all in all, the ratio of this line here is going to be equaling to 5 plus 3, which is giving us 8p. All of us, we agree there. But now, DP is not the whole line. DP is part of the line. How many p's of this, how many p's is this DP? DP is going to be equivalent to 5p. So I'll put this thing here on top. So for me to get BD, I will say BD is going to be given by the ratio of BD all over the actual length. So it means I have 5 of 8 things. Now, what is going to be 5 of 8 things? Multiplied by the actual length, which is what I have. What is the actual length? The actual length is going to be equal to what? 24 centimeters. And then if I type this in my calculator, you can simply check it here. So what I'm going to have, you have 5 all over 8 multiplied by 24. And then it gives us what? 15 centimeters. So this is another way in which you can do it. So how do you do it? You are going to use the ratios to say we have the actual length, and then from there we have the total ratio. And then you say everything all over the total ratio, whatever it is that you are looking for. For example, if I was looking for 80, how would I use this method here? Looking for 80, what should you say 80 is going to be? So I'm going to say that 80 is going to be given by 3p all over the 8 of p, multiplied by 24 centimeters. And then this is going to give us what? 9 centimeters. And then hopefully from here, guys, you will decide. Again, we have triangle ABC, and then we have D. D is going to divide this thing in a ratio of 3:5. So if we say this is 3:5, we come and put this is 3p. This one here it's 5p. And then we want to get the length of AD. Let's start with AD. We'll only do AD here. So if we want to get AD, we'll come and say, what is the actual length? What is the total length of this thing? So the total length of this thing as the ratio, the total ratio length is going to be 8p. So this is the total ratio. And then if we want to get AD, then we'll come and say, okay, AD is going to be given by what part AD is. AD is 5 of the 8. Yeah? So we'll say that we have 5 of 8. And then this is P, but you'll see the P and the P are going to divide each other out. And then multiply by the actual length. What is our actual length here? 16 centimeters. And then we'll say AD is going to be given as, this is going to be 10 centimeters. Now, which one gave us the fraction? Which one was that? It's AE.
Yes.
Okay, let's do AE then. Now, if we come and check this one, they say the ratio here is 2:6. So we can say 2K and then 2K. All in all, the total, the sum of the ratio, it's going to be equal to 8K. And then if you want to get AE, you can say AE. What is AE? AE is 2 of the 8. So you say you have 2K all over 8K, which is going to be multiplied by 18. And then if you do this, what do you get? It's what? It's 9 all over 2 centimeters. Now you can yeah, we had exactly the same story, but it's something that I want you to notice is this. When we're busy with these ones here, we had D and E, line DE, it was a line on AB and a line on AC respectively. So nothing has changed. So here, we're going to have exactly the same the same thing. So you have A, we have B, we have C, and then we have line DE, which is D is on AB and then E is on AC. But now, we need to notice something here. What we're supposed to do here is that let's go and measure, take the following triangle, take the following thing. And then let me do this. Let's take exactly the same diagram and then draw it. So we have the following diagram. And then I've drawn the diagram here on your behalf. If you are able to do it, okay, let's just go and measure some of these things here. We're going to measure what is going to be the length of A to D. Now, if I measure the length from A to D, let's check that. I have A to D. It says A to D is going to be 3 units. For now, we'll just stick to units. So here you have this one as 3. Yeah, we have 3 units. And then if I were to measure the distance, let's measure the distance from D to B. And then from D to B, it gives me something different. It gives me what? 2 units. These are the actual length, guys. These are not the ratio. These are the actual length. The length of D to B is 2. The length of A to D is actually going to be equaling to 2. Let's move on. Let's measure the other lengths. If I measure this one and this one, I get something like 6. Okay, this is 6. Good for me. And then I'm going to measure the last one. If I measure this one and this one, it gives me 4. Not bad. Okay, so I've measured all the different lines that I have. Not all of them, but these are the ones that we are going to need. The next thing that I'm going to do is to measure this angle here. If I come and measure what is this angle here, let's just check. It says it's 18. And then after that, let's measure also this angle here. It's also 18. Now, I want you to come, based on what you just observed here, guys, based on what you just observed, I want you to come and answer the following questions. So now you come here and answer the following questions. Now, we see that this angle here, we've measured this angle, we got it as 18. We've measured this angle here, we've got it as what? As 8. Okay, good for us. Now, what can you tell us? What can you conclude about the line DE and BC? What is it that you can tell me about these two lines? They are parallel, okay? Yeah, okay. They say these two lines. I'm not saying that. You are saying that. You are like, don't blame me if it's wrong, okay? I didn't say that. You said that. So, what we can say about the line DE and the line BC is that these two lines are what? Parallel. Now, why do we say that, guys? That's what I'm interested in. Why are we saying that? So this is 80, this is 8. And then you say to me, DE is going to be parallel to BC. Question is why? That was the question. Why are we saying which of these two things are parallel? You can, in Euclidean geometry, you can't just say things out of nowhere. Why are you saying that? They are parallel. Now, the reason why we are saying these lines are parallel is because we have corresponding angles which are equal. You see these things here. Again, this is an F shape. So if you look at the F shape here, so this is F looking downwards. So if corresponding angles are equal, it makes the lines to be what? To be parallel. If we have parallel lines, it makes corresponding angles to be what? To be equal.
Yes.
Do you get what we're saying? So what we can conclude based on these lines, that's what we are saying. We are saying we are going to say DE is parallel to BC. When they ask us why are we saying that, we're going to tell them it's because we have corresponding angles equal. We should say which because we have corresponding angles which are equal. This is a theorem. Corresponding angles which are equal, they are going to be given by parallel lines. Now, what else do I want us to know? Write the following ratios in the classwork book. Write the following ratios. You got this as 3, and then you got this as 2, you got this as 6, you got this as 4. Write down the following ratios in the simplest form. Just tell us what is going to be AD all over BD, and then tell us what is going to be AE all over CE now. So let's just get the ratio of AD. If we look at the ratio of AD, the ratio of AD is going to be given as AD all over BD. What is going to be the ratio of this thing? It's 3 all over 2. So okay, this is the ratio of AD. Now, if we say what is going to be the ratio of AE all over EC, it's 6 all over 4. Now we can say 2 goes into 6, it also goes into 4 again. So what is going to be this thing in a simplest form? Okay. Yeah. This is 3 all over 2 again. And then this is also 3 all over 2. What can you conclude from this? So you can simply say, okay, it means AD all over BD can be equaling to AE all over EC. And then the reason why we are saying these two things are equal is because they have equal ratios. Now, I'm going to tell you how do we say that mathematically. If two ratios are equal in mathematics, in math we like to be special. We don't say equal ratios. We say these two things are in proportion. So what is in proportion? In proportion, it's a fancy way of saying we have equal ratios. So if you take two ratios which are equal, instead of saying which equal ratios, we say those two ratios are what are in proportion. So the ratio of AD all over BD is in proportion with the ratio of AE all over what? All over EC. Let's come back here. I just want to show us something here. Let's look at something here. We'll come back to the other one. Here, let's look at this ratio. Ratio of AD here. What is the ratio of AD here? We got the ratio of AD. Let's write it. So we have the ratio of AD as AD all over DB. AD all over DB, what do we get here? It's 5 all over 3. So we can say this can be written as 5:3. Let's look at the ratio of AE. So let's look at the ratio of AE is to EC. What is this? Is 2:6. And then if you say 2:6, you can simplify this further. If you simplify this, what are you going to get? 1/3. Now, based on what you just learned now, let's look at these two things. This one here, it's 5/3. This one here is 1/3. Can we say that these two ratios are in proportion with one another? The ratios are not equal. Now, what made these two ratios to be equal? Because clearly we can have a line from one point of the triangle to the other side of the triangle, but it doesn't necessarily mean they are going to be divided into equal ratios. What seems to be making these two ratios to be equal here? What is there which was not here? If you look at this line and this line, they're not parallel again. Now, it seems as if once we have a line, listen to this. If we have a line drawn parallel to one side of a triangle, are you still listening? If we have a line drawn parallel to one side of a triangle, it divides the other two sides into proportion. I should repeat that again. Now, what is in proportion? Let's remember it. What is in proportion? Equal ratios, not equal. Not equal. Equal ratios. Equal ratios. Okay. Now, every time when you have a triangle in a three sides. Actually. So if you have three sides in a triangle, obvious, you are going to draw a line parallel to one side of the triangle. If you draw, so let's say we have a triangle. Obvious, you have a triangle. Okay, you have a triangle. So this is you having a triangle. It's A, it's B, it's C. Now here's what you can do. You are going to draw a line parallel to one side of the triangle. You draw a line parallel to one side of a triangle. Again. Now, here, you can have A, B, C. Which line? We're going to draw a line parallel to one side of a triangle. We should draw it parallel to which line? You choose the line. You choose the line. You choose BC. BC is common. Let's choose AB. So I'm going to draw a line parallel to AB. This is me drawing a line parallel to AB. So I'm going to call this D here, and then I will call this one E. If I make these two lines to be parallel, if these two lines are parallel, what this line that I've just drawn is going to do is going to divide this side and this side into equal ratios. And then we call that the proportionality theorem. A line drawn parallel to one side of the triangle, it divides the other two sides into proportion. So the proportion part shouldn't scare us, guys, because we're saying it's going to divide this ratio, the ratio of this side and the ratio of this side to be equal. The lengths themselves are not equal. Do you get what I'm saying here? The lengths themselves are not equal. Now, where are you going to get this thing? Here it is here. You're going to find it here. In the examination guideline, we have accepted reasons. So the two theorems that we are going to do are the following. We have a line drawn parallel to one side of a triangle divides the other two sides into proportion. That's what we just spoke about. Any line drawn parallel to one side of a triangle, any line drawn parallel to one side of a triangle, it divides the other two sides into what? Into proportion. And then the accepted reason that we use that it says line parallel to one side of a triangle, or we can use the following which says prop theorem. We can use this one or this one, it's up to you. Now, here's the other thing which is also strange. We'll come back to that one. What is strange is this also. If a line divides two sides of a triangle into the same proportion, now we are reversing this thing. If a line divides two sides of a triangle into the same proportion, then the line is parallel to the third side of the triangle. Let's talk about this. What do I mean by this one? So So if I give you the following, again, we have a triangle. And then we have A, we have B, and then we have C. And then here we're going to have D, and then here we're going to have E. Now I've drawn line DE. I'm drawing like DE. Let's put it in green so that you'll see it's a line drawn. Now this line that I'm drawing here, I'm drawing it such that it divides the two sides into proportion. So it divides this S2 is to 3, and then it divides this S4 is to 6. Now, if this line can divide these two things here into the same proportion, what then follows, we can make a conclusion to say that AD is going to be parallel to BD. And then the reason why we are saying that is because these two sides are in proportion. Because this side and this side, they have equal ratios, it makes the lines to be parallel. So, equal ratios make parallel line. A parallel line make equal ratios. Does it make sense? Yes. Equal ratios make parallel lines. Okay? And then parallel lines are going to make what? Equal ratios. And then as I close, we are going to do something like this team. Just going to have something like this. And then we're going to use the theorem. Today, I just want us to use the theorem. So suppose which you are given the following. And then they say calculate the value of X. They just say calculate the value of X. So you want to know what is going to be X. Now we're going to use the proportionality theorem because we are already told that if you can look at this, even if they didn't say it, they are saying DE is parallel to what? To BC. What do we know about parallel lines? What do parallel lines do? They are going to divide this ratio and this ratio to be what? To be equal. For the fact that we have parallel lines, once you have parallel lines, automatically the parallel lines, they divide this ratio and these ratios to be what? To be equal. And then the first thing that I'm going to say to them is that I can write AD all over BD. Then I'm going to say this thing here is going to be equivalent to AE all over EC. But I just can't say this. Why am I saying this? What made me to be confident to say that the two ratios are equal? Why am I saying that? Yeah, it's because I can use the following theorem. There's a theorem which is guiding me to say that. The theorem that says that if I have a line parallel to one side of a triangle, then it means which I can safely equate those two things. The two ratios, I can equate them. So I'll come here and say, okay, here, I have line parallel to one side of a triangle. So a line parallel to one side of a triangle is going to divide these two things into what? Into proportion. And then from here onwards, you can see which is a matter of substitution. We know what is AD. What is AD? What is AD? It's X. So I'll put X all over. What is DB? It's 4, which is going to be equal to, it's 9 all over 3. And then we've seen something like this when we're busy with AMA area rule and sign rule. Do you remember that? So we have something like this. So if we cross multiply here, we have 4 multiplied by 4. It says X is going to be how many centimeters? Let's look at that.
10.
It's 12 centimeters. Then we'll come and put and say this thing here is going to be 12 centimeters. And then as we close, this is going to be your homework then. Yeah, I'm going to do this too at home.